Okay, guys, this is section 1.6 where we study some of the characteristics of exponential functions. We're going to start with evaluating exponential functions. First of all, I just want you to remember the general form of an exponential function where a can be said to be the initial value, which is what happens at the beginning when x is 0. This power b to the 0 turns into a 1, so that is going to be what happens at the beginning, all right? And also take into account that b is what we call the growth or decay factor. Okay, this one determines whether the function is providing you with an idea of a exponential growth as long as b is greater than 0, and it's showing you decay when this b value is between 0 and 1. It cannot be 1, or else we would be talking about a constant function. It cannot be 0, because we would be talking just about y equals 0. And it cannot be negative, right? In that case, we will be talking about a different type of function, but not an exponential one. One thing that we usually start doing is evaluating. We always do that because it's necessary to find out what the output is when we are given a certain input. So we are going to evaluate this function for two different x values. So let's begin. What happens when x is negative 2 and what happens when x is 3? Okay, so when x is negative 2, you have 10 multiplied by 2 raised to the negative 2 power. And now here's where we remember some of the properties of exponents that are really useful when we are evaluating this. This means that now I'm going to take this down, and it means that I've got 10 over 4. And finally, this turns into a 2.5. And then we're done. Now, what happens when x is 3? Well, this is where x is. We don't have to do anything else other than evaluating that power, which is 8. And then you get an 80. And that's all.